Welcome to Study Loop.
So the complex we are given here is PdCl4 2 minus, and it's said that it's a diamagnetic complex, and a complex being diamagnetic means that there is no unpaired electrons in its d orbital, which means that it's a low spin complex, and the low spin complexes prefer having square planar structure. So that means that the complex we have here will have a square planar geometry. But let's have a look at why it will have a square planar geometry, or how we are actually proving that it's a low spin complex. So for that, let's draw the orbital splitting for a square planar complex. For a square planar complex, the d orbital splitting takes place like this. So that's how for a square planar complex, the d orbital splitting takes place. The energy will go in this way. And for a tetrahedral complex, we know that the energy, the orbital splitting takes place like this. So in in this complex, we have Pd as our central metal atom or ion, and Pd2 plus. We can write it here. Pd2 plus has an electronic configuration of um, krypton, and then 4d8. So in case of and since the ligand here is a weak field ligand, which is chloride, a weak field one, so in case of the tetrahedral splitting, the weak field ligand means the energy gap will be low, and electrons will occupy both lower and higher energy level orbitals. 5, 6, 7, 8. So in case of tetrahedral complex, or if the complex you're given here was tetrahedral, we should have two unpaired electrons, and what unpaired electrons means, the complex should be paramagnetic. Now now let's have a look at the square planar splitting. In case of square planar splitting, the 8 electrons will um, take place like this. 3, 4. um, this energy level is a little bit higher in the um, in splitting, and electron will not occupy that one, and they will just pairing up again from the first one. So that's how the d orbital splitting in case of square planar structure will take place. So here we see that there is no unpaired electron here, and that means that no unpaired electrons means diamagnetic. So we can see that only if the complex has a square planar geometry, then it can be diamagnetic. And since it's diamagnetic is mentioned in the question, that means the structure it possesses square planar, not tetrahedral.